this section 2.6, we're going to be talking about perimeters and areas of similar figures. And first off, ratio of a perimeter. If you know the ratio of the sides, then you know the ratio of the perimeter because it is literally the same as the ratio of the sides. And this gives an overly complicated mathematical definition, but I'll show you a better example here in just a second, and you can write this down. But basically, if you know this ratio, then you know the perimeter, the ratio of the perimeter, okay? Keep it simple. Ratio of the area is also simple. It's the square of the ratio of the sides. So if you know the ratio of this, square it, and you got the ratio of the area. And you can reverse that process. So let's just go ahead and hit a couple of problems, and it might make a little bit more sense. So first off, in this one, it says the two figures are similar, so we know they're similar. It says find the ratios shaded to non-shaded of the perimeter of the areas. So first off, let's talk about the ratio of sides. I'm going to put the ratio of sides. Well, we know that we're going to shaded to non-shaded. That means that it's going from 8/3. That's the ratio of my sides, 8:3. Well, because of the definition I gave you about the ratio of perimeter, I'm just going to put RP because now I'm getting lazy. The ratio of the perimeter, according to the definition, it says it's the same as the ratio of the sides. So guess what the ratio of the perimeter is? 8:3. All right, now this is where it gets just a tiny bit more complicated, not by much. The ratio of the area, according to our definition, it's the square ratio of the sides. So what it's telling me to do is to take this ratio, 8:3, and square it. So I'm going to rewrite this as 8 square divided by 3 square. And I can rewrite it one more time. 8 square is 64, and 3 square is 9. And I'm done. That's it. So the ratio of the sides, we just go 8:3, easy. The ratio of the perimeter, literally the same thing. And the ratio of the area is where we take it and we square it. 8 square is 64, 3 square is 9. I'm done. So I'm going to do the same thing on this one. The ratio of the side is going to be 6:10. But here's the thing. I already know, bells should be going off in your head too, that I can reduce this because it is a fraction. I can reduce that to, or I should say simplify, that's a better term, 3/5. So the ratio of the sides is 3/5. Guess what the ratio of the perimeter is? The exact same thing. And now the ratio of the area, a little bit more complicated. We're going to take that and we're going to square it. So that means that 3 square over 5 square gives me 9/25. And I am done. That is it. There's nothing more to that. If you know the ratio of the sides, you know everything. Now, speaking of going along with ratios and proportions, this should be again somewhat of a review from proportions from last year. I have two polygons here. This one, this one is a triangle, and it tells me that they're similar. So find x. Well, I can just rewrite it. I know that these two sides are similar, so I want to write it as 8/3 from the big to the small. And then I'm going to do the same thing. From big to small would be 10/x. Notice what I did. This side and this side, they are corresponding. They are similar, and they are the same side, so I put them together. And then did the same thing with the 10 and x. Now, this should be very familiar to you by this point from proportions last year. You cross, multiply, and divide. How do you do that? Do your butterfly. 8 times x gives me 8x. 3 times 10 gives me 30. Now I divide by 8 on both sides, and I get that x is equal to 3.75. All right, so I found x. Now we're going to literally do the same thing here. These are similar, and I know that this side goes to this. These two sides correspond with one another. They are not. They're not congruent. They just correspond. So we can say x/12 is equal to 7/5. Cross multiply and divide again using the butterfly. X times 5 is 5x. 12 times 7. I think it's 84. Gotta double check myself. Yay, I was right. All right, 84. Divide by 5 on both sides. X is equal to, sound like a mosquito, 16.8. I'm done. I found X. Now, let's go to the word problem. A little bit more difficult here. It says you buy 2 picture frames that are similar. The ratio of the corresponding side lengths is 4 to 5. What is the ratio of the area? All right, so pause. Don't freak out. It's a word problem. Look at what it tells you. The ratio of the sides is equal to 4 to 5. And it's asking you to find the ratio of the area. Well, what do? I simply square this. So I'm going to say 4/5 or 4 over 5 square. Rewrite it as 4 square. Divide by 5 square. Rewrite it as 16 over 25. And notice that they did it like this in this particular case. They put 4:5. We can do the same thing. This should be review again for you. It's the same thing as saying 16 to 25. Remember, I didn't really cover this too much in this video because it should be review. Fractions and proportions and ratios can be interchangeable like this. All right? And also, FYI, for future reference, this symbol right here, believe it or not, especially when you get into higher order mathematics, is shorthand for division. So just keep that in your mind. All right, and that's it for this video. 6 minutes and, nope, 7 minutes now, according to my clock if I have been recording, and I am done. And as always, see you next time.